In this video, we're going to talk about OSI model, stands for Open System Interconnection model. The OSI model tells us how the data transmission happens between source computer and the destination computer. For example, when we talked about client-server architecture, this source computer is the computer where your browser is running and destination computer is the server. Or we can say the communication happens between two applications because ultimately it's two applications or the programs where the communication happens. For example, between the browser and the web server software. Now let me warn you that OSI model is very complex. I'll try to put it simple in this video. So you may not be able to understand this concept in the very first go. It takes a while to digest. And added to that, if you're a Java programmer, you're not really serious about understanding this architecture very deep. Because as a programmer, you're interacting with these three layers that I've pointed out. And rest of the layers is majorly meant for network admins who want to find and fix the problems in the network. For example, if there is some problem with the, say, a router, then they say there's a problem with the layer 3 of the OSI model, the network layer. But anyway, let's take a look at this. Just consider this video to be a bonus video. You don't really need to know very deep, but definitely it's always good to know. In fact, this is one of the basic concepts of networking. Hence, for the completeness of this chapter, I'm going to explain this as well. So first of all, we have some data that needs to be sent from this computer to this computer. The application program could be an application like a Facebook or say YouTube or whatever, the application that runs on the browser. And all the softwares or applications like browsers or Skype or an FTP client, all such kind of softwares or applications that help the user transmit the data will all fall under this application layer. Let's move on to the presentation layer. The presentation layer is kind of like an enabler for application layer to interact with the rest of the world. The presentation layer will do formatting. It will kind of translate the data from the application layer to the data that all the further layers can understand and process and ultimately transmit the data. And then we have the session layer. We've already talked about establishing a session with the server in client-server architecture. That's exactly what it is. This is where negotiation happens between client and server. And so they are good to exchange the data between themselves. Coming to transport layer, there are a lot of things that will happen here. The transport layer is majorly meant for reliably sending the data between the two parties. When we talked about TCP protocol, we've talked about the error correction. For example, if one of the packet is missing, the server is going to ask for it and client is going to resend it and vice versa. And also the order of the packets are guaranteed. I mean the flow control. The flow of packets will retain their order even after reaching the destination. So that all such kind of things will take place in the transport layer. Also in this layer, the data will be split up into so-called smaller segments. So segmentation happens here. Along with that, the transport layer will also append some kind of an information. That information we call it a header. For each segment, there is a header appended. In transport layer, that header is nothing but the port number where the request needs to go or data needs to be transmitted. For example, when we submit an URL, it's going to be port 80 because that's the port where the web server would be running. We've already talked about it. And then the network layer. In the network layer, all the data that has been passed through from all the above layers will now be split up into packets. And network layer is where all the routers operate. And we've already talked about the functionality of a router. It majorly relies on the IP address to deliver the packet to the destination host. So if there is any problem with the router, then the network admin will call out and say, there's a problem with layer 3. And moreover, network layer will also append the IP address as a header. Now let's move on to the data link layer. In data link layer, this is where all the switches operate. And when I say switches, switches majorly transmit data based on the MAC address. And that's exactly the header which gets added in the data link layer. It appends the MAC address of the destination host. And it is in this layer all the data or the packets will be packed into so-called a frame. It's like you're sending a courier, and that courier would constitute multiple packets in it, if you understand it that way. And then lastly, the physical layer, which is majorly responsible for putting all the data into the network, and using the bandwidth the data will be transmitted over the network cables, fiber optics, routers or whatever. And the packets of data will then get transmitted over the cables. Ultimately it would reach the destination. Now so far whatever we have done so far is called encapsulation. Why is it called encapsulation? Because as the data traverses through all these layers down the line, it is appending some kind of a header in each and every layer. So ultimately we're encapsulating the data with header information to reliably deliver it to the destination. And on the receiving end, what happens is the opposite. As and when it goes these layers from bottom to top, it's going to decapsulate. In data link layer, it's going to read the MAC address and it's going to get rid of that header and pass it on to the network layer. We'll make use of the IP address and it will detach that IP address because it's no longer needed. Similarly, in transport layer, it figures out the port number where the data needs to be transmitted. Ultimately, it will end up in that application. And this is just one step. Again, if the server responds back with something, the entire process happens. Encapsulation and then again decapsulation. So by the time it reaches the destination, it is again the same raw data. So that's basically the OSI model. And like I've mentioned, if you're a Java programmer, these are the three layers you would majorly work on. And you're least bothered about the rest of the layers. You're not bothered about routers, switches, how the packets are sent, etc. That's a headache of a network admin. But it's always good to have some idea on this. So you would majorly work on protocols like HTTP, FTP, file transfer protocol, we've already talked about it, and SMTP, for instance, simple mail transfer protocol, helps us to send mails electronically. So all these protocols help the user interact with the network. They all come in these top three layers. And in transport layer, things like TCP and UDP protocols will come into picture. We've already talked about it. And ultimately the entire purpose of this architecture is to deliver the data reliably. And moreover, this is kind of like a logical division of the entire network so that it's easier for a network admin to find and fix a problem. Hope it makes sense. See you in my next video, and we'll start with some coding starting from next video. See you soon.